All right, it is 1:30. I am going to get started. So today we'll first talk about the homework assignment that was due today, because you kind of need to know the solution of that one before working on the new one. So we do have a new homework assignment. I'll briefly take a look at it, and then we'll talk about the components that you need to understand in order to get this new homework assignment done. So we'll start with the solution of the previous one, the one that was due today, and that's recursion 1. And I'm going to do the same thing that you would have to do, which is to download the file first. Okay. Put it into a folder, and then in LibreOffice, open it up. All right, so file open. In temp, it is called recurse1-1. All right. All right, so are you guys ready? Okay. So let's go, new window, and go to the trace. All right, so the trace window, I'm gonna have to use I cannot zoom in as much just because it will take up some space. We'll have comments because we do have the condition to evaluate on line 2. We'll have line number, the usual stuff, and we also need one column per global variable. I just bumped it. That was my fault. There we go. Takes a moment. It will come back. There we go. So we do have a few global variables because every single name used here are global variables. Now, how do we know that x is a global variable? That's an easy one, because x is referred to from outside of a subroutine, so only global variables can be accessed from outside of the context of a subroutine. Then we have the other variable, which is p. P is referred inside, we refer to P inside the subroutine, but P is not a bival parameter because we don't see any bival here. It is also not a local variable because we don't see local P over here. So without any designation like that, P is by default also a global variable. So we have two global variables, and every global variable must have a column allocated at the beginning of the entire thing. So we have x and p. Now, if you reverse the order, that's fine too. There's no particular reason or particular order of how you allocate columns for x and p. So the precondition is both of these are unknown. We then get to line 11, which is the first line of the entire program that is outside of the context of a subroutine definition. And x is getting a value of 3. We get to line 12. We do the invocation. We allocate a return line number column because this is before we talk about the return statement. So everything is just a return line number in this case. In this case, it is post. And then we get into the subroutine. Every time you invoke a subroutine, you always start from the beginning of the subroutine. So in this case, it is line 2, which evaluates whether x is greater than 0. It is true. So we go to line 3. We subtract 1 from x. X is now 2. And then we go to line 4. We have another invocation. So we allocate another column, the leftmost column that is unused at this point. It is column F. And we have, this one is easy, where the return line number should be. It's just the one line after the invoke, which is line 5. Then we go back to line 2, because once we remember where to go back to, then we continue execution at the invoked subroutine starting from the beginning. So we ask the question again. X is greater than 0 is true because x is 2 at this point. Then we move on to line 3. X is decremented by 1. We go on to line 4, and once again we have line number, return line number, and also this time it's just 5. Okay. So you might think, hey, this is similar to the behavior of a loop, because before we also have loops, going around and around, going back to the same line over and over again. So you are absolutely correct if you have made that observation that recursive subroutines seems to be doing what loops are doing. That is entirely true, okay? but it is not the same, not exactly the same. It does have some of the properties of a loop. So x is greater than 0 is still true this time. We go to line 3, it is now decremented to 0. We go to line 4, we allocate yet another column to remember that we have to go back to line 5. So at this point, okay, if you just count the number of columns that we have allocated for each invocation, we have we have 4 invocations right now. Okay, so even though we only have one definition of the subroutine called maybe, we actually have 4 invocations kind of stacked on top of each other at this point. So then what do? Well, every time we invoke a subroutine, we start from the beginning. So we go to line 2. X is greater than 0 is no longer true. It is now false because x has a value of 0 at this point. 0 is greater than 0 is false. So then what do? Well, we go to the else branch, which is on line 8. This is the time when we say, okay, variable p, now you start with a particular value of 1. Is that okay? So that's all line 8 has to do, and line 8 is the only thing of the else branch of the conditional statement. So after this, we're done with the conditional statement, and then we proceed to the end of the subroutine, which is on line 10. So at the end of a subroutine, okay, we got a few things to do. We have to locate the rightmost column that is still in use with a column label of return line number. So this time we'll go to column H. Column H tells us to continue execution on line 5. But then once we have made a note of that, then this column is no longer in use. So we'll mark it as unused. So this column is now unused, and we can reuse it if we need to. And now we're back to line 5. Line 5 is right here. It says, okay, let's add 1 to x. X is now going from 0 back to 1. And then we go to line 6. P gets p times x. P has a value of 1, and then x has a value of 1 as well. 1 times 1 is 1. And then we use that to update variable p. And after line 6, we are done with the then branch of the conditional statement. Yes?
After line 10, why would you go to line 5?
After line 10, why did we go to line 5? You're talking about this part here, yeah. Right? Okay, so line 10 is the end of a subroutine. So what do we do at the end of a subroutine? We have to... Okay, go ahead. The rightmost. Okay. The rightmost column that is still in use but labeled return line number. So at that time, at this moment, what is the rightmost column that is still in use and has a label of return line number? Column H. Column H tells us to go to 5. That's why we put a 5 here. Is that okay? So we are basically, quote unquote, backtracking. We left some crumbs behind us as we go further and further into the forest, as we make turns. But every time we finish a turn and we want to go back to retrace our steps, we follow the crumbs that we left behind so that we know, oh, okay, when we get to this point, we need to make a left turn to go back to where we came from. And that's what this 5 really is it is a little bit of a crumb that we left behind so that when we backtrack, we know which way to go back. Is that okay? All right. So now we are on line 6. After line 6, we go to line 10 because line 6 is the last line of the then branch of the conditional statement. And after the conditional statement, there's nothing else. So we are hitting the end of the subroutine again. So we'll do the same thing, except this time we're not going to use column H because column H is not the rightmost column that is in use. It is no longer in use. You know, the strike through, you know, is identifying that this column is not used at this point. So the rightmost column that is in use and has a label of return line number is now column G. Column G also tells me to go back to line 5. So we just say, okay, we'll continue on line 5. And now we also have to mark that column G is no longer in use. Is that okay? But at this point, I'm not even thinking about why did I put 5 here? Because that was done in the invocation. Okay, at this point, I'm just making use of the crumbs that are left behind. So we're back to line 5. What do we do? Well, follow what line 5 usually do. Add 1 to x, okay? And then on line 6, we multiply p and x, and then we store the product back into p. So p is now 2, and then we get to line 10 again. When we get back to line 10, we have to do the same thing. Look up the rightmost column that is 1 in use and 2 labeled return line number. That would be column F at this point. It also tells me to go back to line 5. Okay, so we just say, okay, the next line is going to be line 5, but we also want to make sure that we are no longer marking F as being in use. It is no longer in use. So now we're getting back to line 5 again. Line 5 is, once again, adding 1 to x. X is going from 2 back to 3. And then on line 6, we are multiplying 2 and 3 together. So that becomes 6. Okay? Sorry? Okay. So after line 6, we go back to line 10. And once again, we have to locate the rightmost column that is in use and also labeled return line number. It's going to be column E this time, which tells us to continue execution at post. But before we go there, we have to make sure that column E is now marked as unused. And then we continue execution at post, which is saying we're done. There are no further lines to track at this point. So this is a clumsy way, okay, to calculate factorial. 3 factorial is 6. Okay, n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. Okay, now the significance of factorial is not going to be discussed in this class, but if you attend CISP 440, if you sign up in CISP 440, which means it will be at least 2 or 3 semesters from now, we'll talk about factorial in a much more detailed way. Okay, so right now we're just saying that this is the correct result of the trace of this particular program. Do we have any questions? So one thing you can do, okay, is to look at my trace, look at my solution, and then look at yours and compare those two. Okay, if somehow the numbers are not the same in your trace, you want to find out why they are different. Okay, what is the first step that your trace deviates from this particular trace, and then you want to be able to explain it. Okay, so for that purpose, what I'll do is I'm going to save this file and go to Canvas, and I will upload it. I will send it to you by announcement, which means you probably will see this as an email from your apps.losreals.edu account. So we'll say solution of recursion -1-1, and here it is, and I'll just attach it here, and it is that file. It is already saved. I'm pretty sure it's all saved, and click save. So now you have a copy of the same spreadsheet, which makes it easier for you to compare your answer with the key. Now, if you say my answer is exactly the same as yours, good job. Okay, that means you're fully understanding the concept of invoking a subroutine and returning from a subroutine, and also how to access the variables. On the other hand, if your trace does not look the same, then you want to find out how they are different, and you also want to be able to explain why they are different. When I grade it, I can tell they're different, okay? And I can assign point values depending on what I think is the misunderstanding, but I'm not you. Only you understand how you approach the problem. So this is one chance for you to kind of double check and make sure that your understanding of subroutine invocation is all good. Are we doing okay so far? All right. So now we'll take a look at the new homework assignment. The new homework assignment is also due in a week, so that you have a week to work on it. I will try to work on it over the weekend because we have 5 days before meeting again on Tuesday. So it would be nice for you to start working on it over the weekend. And if you have any questions as you work on it over the weekend, then you can bring those questions on next Tuesday, and then we can talk about it. So this is your new homework assignment. It's called Fibonacci. And you can see there are two Fibonacci's on my screen because one is from the previous time I taught this class. I changed it a little bit, so the one that you see is the correct one. So I'll click on this one, and you can see the format is almost exactly the same as the other one, except the file name is different. That's the only difference between the two homework assignments. And there's only also one difference here. The key to get this assignment done right is this part is also changed a little bit to reflect the focus of this homework assignment. This assignment assumes that you already understand how to invoke a subroutine and how to return from a subroutine. It expects that you understand all the conditional statements, global variables, and whatnot. What it is particularly trying to get you to practice would be how to deal with a by value parameter and also how to return a value from an invocation. So those two specific concepts are used in this homework assignment. Okay? Which also means, if you think you may not be fully understanding those two concepts, it will be helpful to review the material first before attempting the homework assignment. Yes?
You can't download that.
It says unauthorized. Okay, let me see if I can do it here. And it gives me view. Okay. Thank you. Thank you for letting me know, and I'll see if I can fix that. Okay. So remove the entire link here. Go to Files, and then go to fib.ods. And we'll try again. Right click, save link as, and it's still view. Is working? Okay. If it's working, I'm not gonna mess around with it. All right. So, but I do need to get back to that file. So I'm gonna refresh my browser first and see if I can download it. Save link as. Okay, it does work. So I had to refresh it. I forgot to refresh it the other time. Okay, save it. And then we go to LibreOffice. Can I close this one?
Yeah.
The one for the previous assignment? Okay. So I'm going to close this one so that we don't get too many applications on the screen at the same time. And then I can reopen LibreOffice and open this particular homework assignment. So we say open, and I think I save it as just fib.ods. There we go. And zoom in a little bit. There we go. And let me just line things up a little bit differently so it's easier for us to capture it. There we go. All right, so the first thing we'll do is we're going to go through this pseudocode line by line so that we can identify those concepts. Starting with the definition of Fibonacci. Bi-val x, okay? What that's telling you is x is a bi-value parameter. Now, a bi-value parameter basically is kind of like a local variable, except the initial value is given by the invoke statement. And then we only have x over here. Y is referred to only after the definition of the subroutine. So y is a global variable, okay? X is a bi-value parameter. So now we look into the conditional statement. The conditional statement says if x is greater than 2, then we have this return statement, else we have this particular return statement. In other words, if x is less than or equal to 2, we simply return the value of x as it is. Is that okay? If it is not, then we have a complicated thing going on because we are returning a value. But what is that value? Well, we know the value is a sum of some kind because of the addition. But what are we adding? the first thing we're adding, or the first component of the addition, is the result of invoking Fibonacci again. But this time we are passing x minus 1 to x. So this x here is referring to the x of the current invocation. This x here is referring to the x that we are setting up for the next invocation. So I'll give you an example to show exactly what is going on with this. So when this invocation is done, it should be replaced by a single value, okay? A single numerical value. Then what do? We still cannot perform the addition because we have the other invocation. So then we have to resolve what the other invocation is going to return. Once both invocations become numerical values, then we can go ahead and perform the addition, and then we can actually perform the return operation. Is that okay? So that is the tricky part, okay? Is we are combining a few concepts into one single line. And the question is, how do we deal with those concepts on a single line? Now, each concept is still the same as how they were described and illustrated. So we are really just doing the same thing, but you just have to keep your head clear about which part are we doing, okay? So are there any questions about this particular homework assignment, about the pseudocode itself? Is there anything I can clarify at this point? Yep.
Which X are we using on line 4? When we're
On line 4, so on line 4, the X to the right-hand side of the right arrow is telling you the name of the parameter that we are setting up. X minus 1 is the argument. So remember the concept of an argument versus a parameter. The argument is what the invocation is trying, what is the value the invocation is trying to supply to the parameter. The parameter is identifying what parameter, if there's more than one, are we talking about. Now, in this case, there's only one parameter, so it really is not necessary to use its name because, hey, there's only one parameter. But since I want to be consistent with the syntax that I use in this class, I still do that.
it's pretty much 3 minus 1. Pretty much 3 minus 1.
It'll be x minus 1, so it depends on which invocation we are talking about. So within the first invocation, it'll be 3 minus 1 for the left invocation, and it will be 3 minus 2 for the right invocation. All right. So I'm going to show you at least 2 sample programs to help you with this homework assignment. Okay? Yes?
Are you going to put it on the same file so we can look at it after?
I suppose I can. All right, so we'll start with factorial, okay? So I'm going to say define sub, factorial. It has one parameter which is passed by value. I'll call this n. And I say if n is greater than 1, then we do something which is invoke factorial, or return, invoke factorial, and then we'll use n minus 1 to specify n. Else, we'll return n. And if, actually I shouldn't say and here, I should say 1. Okay, give them line numbers. Like so, and fix the indentation. Oh, I forgot this n defines sub here, so we'll need 10 here. Actually, we only need 1 line. We can get rid of that, and then we can say x is invoke factorial. I think 3 is good. Okay, so we'll use 3 to specify parameter n. And then it's time to fix the indentation, because I think most people should agree at this point that indentation is in fact useful in making the program more readable. So we'll go ahead and do that. Okay. And you can see how, structurally speaking, this program seems to be very similar to your homework assignment. But trust me, the trace is going to be quite different. Your trace is going to be a bit longer because there are 2 points of recursion, inside the subroutine. This one only has 1 point of recursion. All right, so this is the code, and now we want to trace it. Okay. All right, so this is my trace window. We can zoom in just one step or two. Okay. We need comments because there is the condition on line 3. We need line number, and we also need one column for x because x is a global variable. Okay, the precondition is x starts with an unknown value. That's pretty standard. We go to line 9, and we have to invoke the subroutine fact. So in this case, there are a few things that are different between this homework assignment and the one that I just went through. Because factorial returns a value, I can no longer use return line number to keep track of what I need to do when we come back from an invocation. I need to use return info now. Okay? So in other words, I'm not using a single line number to remind myself what I need to do after the subroutine is done. I need a little bit more than that. So the return info in this case is I need to go back to line 9. When the invocation of factorial is done, I need to get back to line 9 because I need to finish the assignment operation. Okay? So when I do get back, just hold on one second. I need to finish the assignment operation, but the invocation itself should then be replaced by a single value. Yes, go ahead.
If you started on line 9,
Uh-huh.
the return info, wouldn't it post after instead of line 9 to the other?
Okay, it has to be, I have to go back to line 9 to finish the assignment. Because the invocation is only taking care of this part. Okay? It will take care of this part and replace this part here with a single value. But then what about the assignment operation? I cannot get to post because if I get to post right away, then x would not be changed. So that's why I still need to go back to line 9 to finish the assignment operation. Is that okay? That's a good question because it really helps to show the difference between a subroutine that does not return a value versus a subroutine like factorial that does return a value. Okay? Okay, besides that, what else do we need? Well, factorial has a parameter. It's called n. So n as a parameter starts with a value that the invoke statement is applying. According to line 9, we are using 3 to specify the start value of n, so we just put a 3 here. Do we have any questions up to this point, of invoking factorial on line 9? Are we good so far? Okay. So then where do we go? Well, we go to the first line in the subroutine that is being invoked. In this case, line 1 and 2 do not do anything, so we start with line 3. Line 3 is the beginning of a conditional statement, so we have to say n is greater than 1 is true because n is 3 at this point. Then we go to line 4. So when we get to line 4, you would say, well, eventually, okay, the last thing we want to do is to return a particular value. But I cannot do that yet because I have to first figure out what value am I returning. And the only way to figure out what value we are returning is to invoke factorial again, but this time using a different argument to supply to n. Is that making any sense? So I cannot carry out the action of returning. I can only do this, okay, because I have to invoke factorial again. So I set up return info again. But this time I say when this invocation is done, let's go back to line 4 because I still need to return. Oh, actually, I forgot one thing here. So let me change the program a little bit because I forgot to specify this thing. The invocation or the value of the invocation needs to multiply n. That becomes the product becomes the value that I want to return. So I made a little poo-poo here. Okay, okay, you first. Huh? Yes, we are recording. Yep. It won't show because it is recorded as private. So at the end of the class, I will open it up to public. So right now, it is not going to be listed as public. Yep. If you guys think it might be helpful, to have it live, like not private first, I can change the setting, but I don't want to change the setting in the middle of the recording. It might be helpful in the sense that some people may want to kind of go back a few seconds or 20 seconds or so and find out what I said, but that would actually be not so good because when that person is going back a few, like 20 seconds, that person would not be paying attention to what I'm saying right now. So it's probably better in class just to tell me that you need to stop, and then I can stop and you can revisit a topic that we talked about earlier. Okay, so let's go back here. Okay, so now I have to keep an eye on which part is still on the projector. All right, so line 4 still has a few things to do. The invocation would give me a single value in place of invoke fact, n minus 1 goes to n, but we still have the multiplication by n to perform, and then we have the return to perform. So there are a few things we have to do on line 4 when this invocation is done. The next thing we have to do is to set up another column for n. So here's the question. What should I pass to n in this case? In other words, what should I put into this particular cell? It'll be 2. Exactly, because we are on line 4. The expression you are evaluating is this one. The current value of n is 3. 3 minus 1 is 2. So we are setting up the new parameter n, which is column G, to be 2. So this is where you might want to spend a few moments just to make sure that you understand what is going on here. Okay, the right arrow, what is left to the right arrow is an expression. That expression is your argument. It is what the invoke statement is trying to say. Oh, parameter n, you should start with that value. Is that okay? All right? Because this is needed for your homework assignment. Yes?
Where'd you get 3 from the value of n? Is that from line 9?
Yes. So this 3 of n is set up when we were on line 9. When we invoked, that's how we set up parameter n. Yep.
So pretty much every invocation has to set a new value for n.
Potentially new, yes. It depends on what expression you use to pass to n. All right, so when this is all done, we go to the beginning of the subroutine starting on line 3. And this n is not referring to column E anymore. This n is referring to column G because we always use the column that is in use, rightmost, and has the same label as the variable that we are or parameter that we are referring to. But that n is 2. Okay, this n here has a value of 2. 2 is greater than 1 is true. So now what do? We go to line 3. Oh, we go to line 4. And then we do this all over again. Yes? Why we go back to 3? Because line 4, okay, when we were here, this is the first time we get to line 4. This particular line 4 in this invocation. So ultimately, we want to do the return. That's the last thing we want to perform on line 4 is the return. But I cannot do that. I cannot do that because I don't know what value I'm supposed to return. I know what n is. N is 3 at that point, okay? But the other number, the other value is based on another invocation of factorial. So what I need to do is to invoke factorial. As I invoke factorial, I will go through the same motion as earlier, which means I have to allocate one column for return info and one column for each local variable or parameter. Is that okay? Okay. And as every single invocation, when you're done with setting up the columns, you always start execution from the beginning of the subroutine that we are invoking. So that's how we got back to line 3. Okay. So once again, we get to line 4. And when we get to this line 4, it is the first time. Okay. What do you mean by first time? This is the second time. No, this is the first time we get to line 4 for this particular invocation. So invocation has to do with which columns is the context of that subroutine execution. When we use the context of F and G, that's one context, that's one invocation. But in this case, so the previous time we get to line 4 is in the context of column D and column E. This time we get to line 4 is in the context of column F and column G. That makes this the first time we get to line 4 in this invocation. Are we doing okay so far with that concept? Okay. So being the first time, that means I have to look at this and say, well, I want to do the return, but until I know what value I'm supposed to return, I cannot do the return. But what value am I supposed to return? It's a product because of the multiplication. I know what n is because n in this particular context or in this invocation, n has a value of 2. Not a problem. What about the left-hand side of the multiplication? Oh, darn it. It's based on another invocation. So now we have to set up the third invocation of factorial. Are we doing okay so far with these concepts? Yes? No? Okay. Do we agree that we are now on line 4? Or how we got to line 4? Yes? Okay. Can we agree that this is the first time we get to line 4 from the context of column FG? Okay? Because if you look at, okay, so if I highlight the columns, I think it will make it more obvious. So if I highlight these two columns, okay, and you ask, of all the highlighted cells, which ones, is this the first time? The answer is yes, it is the first time we get here. Are we still okay at this point? Yep.
Starting on line 4, when it says return, what exactly does that mean? Return something. Like in that context.
It has the same meaning as return from the previous class. So when we execute the return statement, we are taking the value that is returning and we locate the rightmost column that is in use that has a label of return info. We copy and paste it, and then we change the question mark to the value that we are returning. So that part has not changed. Okay, the meaning or the action that we need to take when we are returning is the same thing as what we did on Tuesday. Is that okay? But we cannot do that because we don't know what value we are supposed to be returning, because the value that we are supposed to be returning is a product. Now, there are two numbers that I need in order to calculate the product. One is n. N is not a problem. I know exactly what n is. The other side is the value of the invocation of factorial again. That I do not know. I do not know what value is going to be returned by this invocation of factorial until I invoke it and until it returns. Yes?
So what is the difference between two n? The n outside of it and the n inside?
This n is not in the context of any invocation. So this n here has the same thing. It's basically the same as that n. Yep.
Why is there a question mark? If we know n equals 2 and it's n times n, would it not be 4?
You mean this question mark here?
Yeah.
What do you know about this invocation? How do you know the result of that invocation?
But it says, because it says n minus 1, so that's how we got 2, right?
This 2 is due to this n minus 1, yes.
Yeah, but shouldn't that be in place of the question mark is what I'm trying to say.
In place of the question mark. The question mark is representing which invocation are we dealing with. And there's only one invocation of factorial on line 4, so that's the only thing that can be replaced by a question mark. Yep.
What if there's 2?
Huh?
What if there's 2?
Why is there 2?
What if there's 2?
What if there are 2? That's also something that we looked into on Tuesday. Remember Johnny and Brian? Yep. So we did talk about what happens when there are 2 invocations, but the operator that we worked with on Tuesday was an addition. Okay, slightly different operator, but same concept. So we do have that in place, okay? So if you watch that video on Tuesday, or if you fully understand the concept that we talked about on Tuesday, that part is not the main issue here. Is that okay or not? Hmm? Okay, so let's finish this first, and then we'll see, whether that gives you a better sense of what's going on here. When we get to line 4, we have to call the subroutine again in order to figure out what value is returning. So whenever we call a subroutine, we have to do a return info cell and also one cell for n. Return info this time would still be the same as line 4, and we still have this much to do when we come back from this invocations. So it looks exactly the same as what we have in column F. N, on the other hand, is different, because when you look at this line here, when we execute this particular invoke statement, this n is referring to the n that I already have, which is 2. This n is referring to the column that I'm setting up right now, so we are specifying that to be 1 here. So let me point it one more time. This n is referring to the n that I'm already using. This n here is setting up the new n, the new invocation that we are trying to set up. Okay? Yep. Why is it 1? Because it is n minus 1.
Oh, so
this n refers to this n here. So this expression n minus 1 gives me the value that I use to initialize the new parameter n.
Oh, so you take the previous n and you just subtract it by 1.
Well, it just so happens that the n parameter that I have has the same name as the parameter that I'm trying to set up. Okay, I will use another example to illustrate that part. Okay, so let's finish this one first, and then we'll proceed and use another sample program. We get back onto line 3. N is greater than 1 is false, because n is 1 at this point. So when n is false, where do we go? Instead of line 4, we go to line 6. Okay, very good. So this will answer the question of what return does. Okay, so I'm going to say that one more time. Okay, you might want to write it down unless you already understand the concept or know where in the notes to look it up. When we execute a return statement, meaning the value that I need to return is known, this is what we do. We locate the rightmost column that is in use and labeled return info. We copy and paste that cell. So in this case, we'll be copy and pasting this particular cell, which is H10. Okay. So hold on a second. So we copy and paste it, okay? And then we locate a question mark. There should only be one single question mark. If you see multiple question marks, something is not right, okay? There should be only one question mark. You take away that question mark, and then you replace the question mark with the value that you are returning. Whatever value is whatever the expression is on the right-hand side of the word return, once that value is known, then we can replace this question mark with that particular value. Now, since we're on line 6, what value am I returning? Do I know that value? Is it known at this point? It's a constant of 1, right? So we know that value. So now we replace the question mark with this 1 here, and I'm going to boldface it so that we can see that it is important. Okay? Is that okay? And that's it. This is the only thing a return statement is supposed to do. Once you know what the expression is, what is the value of the expression, and you execute a return statement, this is what we do. Is that okay? We just replace the question mark and nothing else. After line 6, where do we go? 8. Line 8. So at line 8, we're at the end of one invocation. So what do we do when we're at the end of an invocation? We locate the rightmost in-use column that has a label of return info in this case, because this particular subroutine does return a value. So we have to look for return info. So that column turns out to be column H. Okay? So, and the value is this. So instead of tracking things in a slightly different way, we'll just copy and paste this entire cell over here. Because this tells me which line I need to go back to, and more importantly, what else do I need to do on that line? We doing okay so far? More or less? Okay. And at this point, both of these columns for this invocation are no longer needed because we are at the end of the entire subroutine. So both columns are deallocated. So we just strike through both to indicate that column H and column I are no longer in use at this point. Which means if later on you need additional columns, you can reuse column H and column I. In this example, that will not happen, okay? But in your homework assignment, it might happen. So you have to keep track of which column is in use and which column is not in use. And whenever you need to allocate a column, you have to allocate the leftmost column that is available. So don't forget that part. All right. So now we are getting back to line 4. But we are not just getting back to line 4. If I'm just getting back to line 4, I'll be doing the invoke all over again. But that is not what we need to do because the invoke is already done. It's telling us that the invoke gives me a value of 1. Is that okay? So now, am I ready to perform the multiplication? Do I know the values of both sides of the multiplication on row 14? I think so. One side is a constant of 1. Okay, no problem. The other side is n. Which n am I referring to? Okay, so how do we find which column? It is the rightmost column that is in use and is labeled n. Which column would that be? Column G. Column I is not in use anymore. Okay? So you have to look at this row, and then you basically from this row you look up and see if it is still in use. It is not in use anymore. Column I is not in use. Column G is the rightmost column that is 1 in use, and it is also labeled n. So this time when we say 1 times n, that n is column G, which has a value of 2. 1 times 2 is 2. Are we still doing okay so far? Okay, so this expression is giving us 1 times 2, which is 2. Oh, so we know what value we need to return. We need to return a value of 2. So that means we are now ready to execute the return statement itself. Is that okay? What do we do when we execute a return statement? I think I need a recorder that has a few buttons. One button says, when we what do we do when we return. When one button says, what we do when we're at the end of a subroutine, and one button says, something else. Locating the rightmost. Exactly. You got it. So we are looking for the rightmost column that is in use, and it has the label of return info. Okay. So which column would that be? F. Column F. Very good. So we take this, we copy and paste it. And then what do we do? Cross out what? We cross out the question mark and then replace it with 2 because we are returning 2. Now this looks awfully confusing, doesn't it? But that's because you're overthinking. Because you are paying attention to things that you really do not need to pay attention to. Okay? Because if you listen to what I said, okay, I never said anything about what to do with this return, why this can be returned. I didn't say anything like that, did I? I only said locate the rightmost column that is in use and it is labeled return info, copy and paste the cell, replace the question mark with the value that you're returning, which is 2. Now, what if that cell itself is also a return statement? I don't care. It is not a problem for me. My job is to locate the question mark and replace the question mark with a value. What if the question mark is on the right-hand side of a return? It is of no concern to me. Is that okay? Because that is why some of us are getting, thinking, this is what is leading us to overthink, is we are thinking, but this is also a return, this is also a return. It doesn't matter. Column B is what we do. Column F is only for tracking things. Is that okay? Yep. Question? Nope. Okay. So now what do? We're done with line 4. So after line 4 is done, where do we go? We go to line 8, and line 8 is the end of a subroutine. What do we do at the end of a subroutine when the subroutine can return a value? Not yet. Okay, I really need to set that up, set up a little app that has all the buttons. Okay, when we are at the end of a subroutine, we locate the rightmost column, that is in use and labeled return info, right? And then what do? We copy and paste it to the line number column. So in this case, the rightmost column that is in use and labeled return info is this column, column F. We look at the last update of that particular column, and then we copy and paste it into the line number column. Yep.
So you only put it in the line number column when you're ending the subroutine?
That is correct. Only when you're at end define sub do you copy it to the line number column. And then we have to remember to cross out these two columns, and remember that these two columns can now be used again if we have a need to use additional columns. So once again, this particular example does not need to reuse a column, but your homework assignment has situations where you have to reuse a column. Then after this point, column F, G can be reused again. Are we still doing okay so far or not? Maybe? Okay. So the next example, I will show you something that is less confusing, just because it's not recursive, it uses different subroutines, and the name of the parameters are different. Okay? All right. So now where are we? We are back to line 4. But when we're back to this line 4, can I perform the multiplication? Do I know the values of both sides of the multiplication? Yes, we do. Okay, we have a constant here, no problem. We have a reference to n. What n am I referring to? How do I know where to find n? The rightmost in use column that is labeled n. And which one would that be? Column E. It has a value of 3. So knowing that we have 2 on one side, 3 on the other side, this is a multiplication. Can we figure out what value we're supposed to return with this line 4? We're supposed to return 6. Okay, very good. So we can go ahead and execute return 6 now, right? What do we do when we say return 6? When we execute the statement return 6. We look up the rightmost in use column that is labeled return info, copy and paste it, and then we replace the question mark with the value that we are returning. Remind me again, what are we returning this time? 6. Okay, replace it with 6. That's all. So the return statement, all it does is to replace a question mark with an actual value. That is all it does. Now, if you replace it with n, replace it with something other than an actual numerical value, something is not right. Okay? If you see 2 question marks in a return info cell, something is not right. It can only have 1 and only 1 question mark before you say return. Is that okay? Yep.
In row 14, we also had both of the number was clear, like one of n is 2 and another n is 1. And why we didn't replace that?
Okay, on row 14. Okay, what was the question again? On row 14. Okay, so let's go ahead and re-execute row 14. Okay, this is the best part of tracing a program using something like this, is we can roll back in time and redo something and not get confused. So let's just say that we have not done the rest, okay? This is the first time we get to row 14 of the trace. So when we get to row 14 of the trace, line 4 looks like this now. In other words, the invocation is now resolved to a single known value. Are we good so far? So we are executing return 1 times n. At that point, what n am I talking about? We use the same method. We look up the rightmost in-use column that is labeled n. So you scan and you go, oh, okay, column G is what we're referring to, which is 2. So you know n is 2, so 1 times n is 1 times 2. That gives you a value of 2. So the action you're performing is returning a value of 2. When you perform the action of returning a value of 2, what do? You locate the rightmost in-use column that is labeled return info, copy and paste, and then change the question mark to 2 in this case. So when we execute the return statement on row 14, we look up the rightmost in-use column that is labeled return info. It cannot be column H because it is already gone at this time, so it has to be column F. Copy and paste it, replace the question mark with a value of 2. That's it. That is the end of executing a return statement.
Why there we have still times n?
What? Say again?
Why still we have there?
You mean
times
here
n? Yeah.
or
Times
here?
n? No.
This one?
Yeah.
I don't care. Why would I care?
It's changing.
You are overthinking it.
It should be the same as 16 because here we
Say that one more time. Wait. What should be the same as 16?
And row 14, when you're doing 1 times 2,
Uh-huh.
we shouldn't have n anymore because we already
Okay,
already
are we settled on line 4, row 14 is okay? Yes or no? Is row 14 okay, or should we go back to row 14? Yep.
So on row 14, we go from line 8 to line 4, right?
On row 14, we went from no.
Line number 8, we went to line number 4.
Okay, are you going from in this direction or going in this?
13 says 8, right?
Yes.
Line number 8.
Yes.
After line number 8, we do end define, that takes us back to 14 to return.
Okay, so what do we do when we're at the end of a subroutine? Now, when you end at the end of a subroutine, you cannot proceed after this point, right? Because it's the end of the subroutine. So the only way you can proceed is to say, did I leave any crumbs earlier so that I know where to go back to, right? And did I leave any crumbs? Okay, so how do we know which piece of crumb do we use to return? So let's say we're back to row 13, okay? On row 13, when we get to line 8, what do? We locate the rightmost column that is in use and labeled return info because that is the crumb that I left behind to tell myself where I need to go back to after the end of a subroutine. Is that answering the question? So when we are here, this is before this is deallocated, right? So the rightmost column that is in use and labeled return info was column H at that time. So what we do is we look up column H and say we will take the last update of column H and copy and paste it into the line number column. Why do we do that? Because that is what we need to do next. Okay? Now why not just say line 4? Because line 4 involves the invocation, which is already done at this point. And that's why we don't want to just say line 4 on row 14. We want to say line 4 now looks like this. There's no invocation anymore because we are done with that invocation. Is that okay?
Yeah, it's good.
So we're good? Okay, excellent. Good thing this is all being recorded. Let me check. Yes, it is still being recorded. Okay, so are we okay with up to row 16, or should we replay line 14, row 14, 15, and then 16?
No, we're okay.
Sorry?
We're okay.
We're okay? All right. So does everybody agree that we are okay? Okay, no objection? Okay. So we are now back to row 16, okay? And we are done with executing row 16 because, because row 16 needs to compute 2 times n. I know what 2 is. I know which n this is referring to. 2 times n is 6 in this case. So we are executing return 6 in this case. Return 6 means we need to locate the rightmost in-use column that is labeled return info, copy and paste it, replace the question mark with a 6 in this case because we are returning a value of 6. That is exactly what happened. Because at that moment, the rightmost in-use column that is return info was column D. Copy and paste it, change the question mark to the value that we are returning, and we are done. What that cell, what the return info cell has is irrelevant to me. The only thing that I'm looking for is the question mark. And I'm only replacing the question mark with the return value. That's it. What if it is also a return statement? What if it's an if statement? I don't care. None of my concern. Okay? So now what do? After line 4, we get back to line 8. So at line 8, we got a few things to do. We look up the rightmost in-use return info cell, and then we copy that into the line number column this time, because this reminds us what do we need to do after the end of the subroutine. Okay? And then we need to deallocate column D and E. So I'm being a little bit lazy here by copy and pasting the struck out version. And now we are continuing execution on line 9. Well, can we perform the assignment operation at this point? Is the right-hand side known? Yep, it's just 6. Do we know where to find x? Yep, x is a global variable, pretty easy to find. So now we update global variable x. I misspoke, this is a global variable. We replace this with a 6, get to post, and we're done. Is that okay? So instead of, so there are a few things going on here. There's the mechanical aspect. Okay, what mechanical aspect are we talking about? Locate the rightmost in-use column that is labeled return info. That's mechanical. Okay, copy and paste it, mechanical. Replace the question mark with something, blah, blah, blah. Those are all mechanical. But you have to remember the reason why we are doing it. What is the semantic? What is the meaning of doing it? The setting of the columns, okay, especially the return info cell, is to leave behind crumbs so that we have a way to go back. Okay? The question mark is a placeholder for a value that the invocation will provide by executing return statement. Okay? When we at the end of a subroutine, whenever we step on line 8, we copy and paste, we copy the last value, the last update of a return info cell to line number over here, because that is exactly what we need to do when we get back to that line. I cannot use a single line number, because if I use a single line number, that invocation will still be there. But the invocation is already resolved with a particular value. So I need to remember that when we get back to line 4 and say, hey, on row 14, the invocation is already resolved to a single value. I can now evaluate what is 1 times n. And as a result, I can execute the return statement itself, which then becomes another chunk of mechanical steps in getting the whole thing done. So is that okay? Yes?
The whole process was about to find the value for the x.
That is correct. However, this doesn't even have to be an assignment operation. It can be, okay, let me give you another example. Are we ready to move on to another example, or are there any specific parts of this trace that you want me to go over? This is really similar.
No, because usually the homework goes back into it returns into a return thing. You know what I'm talking about?
This has a return to a return.
No, you said the homework would be more complicated though, because there's something else to it.
Well, that's because you have a whole week to work on it. Yep.
Said in return info there only should be one question mark, but in our homework I think there is two because plus two invocation.
You can only do one at a time. So for that, okay, so the question, let me repeat the question. The question was, because in this case we only got one invoke, that's why we only have one question mark. But in the homework, we have two invokes on the same line. So shouldn't that will generate two question marks at the same time? The answer is no. We should not generate two question marks at the same time because of the example that we went through on Tuesday. 5 and Ryan, Johnny and Ryan, okay? In that example, we have invoke Johnny, and then we also have invoke Ryan. But when you trace that through, every single time we have a return info cell, that's only up to one question mark because we only handle one invoke at a time. When we get back, we go like, oh, there's another invoke. Then we replace the other one with a question mark. So the question mark is basically indicating which invoke is currently being handled. And you cannot handle two invokes at the same time. Is that okay? Yep.
Every piece of code does something, and I'm curious, what does this code does?
This code does factorial. It computes factorial and stores it into X.
Factorial of what?
Factorial of 3. Mm-hmm.
If we
Which is,
find the factorial of 3 mathematically, it will be 6 too.
say that one more time.
If we find the factorial of 3,
Uh-huh.
it's gonna be 6.
Yes, 3 factorial is 6. And yeah, go ahead.
So this is pretty much half of the homework quiz. Give or
It is, in terms of number of rows, it may not be exactly one half, but in terms of, what you need to understand, this illustrates a good portion of what you need to do in the homework assignment. The only part it does not explain that relates to the homework assignment is what if you have two invokes in one expression on the same line of a return. But that is partially explained on Tuesday when we have Ryan and Johnny. Remember what those two represent? Johnny is representing 5 because of the robot, right? Johnny 5. And then Ryan is representing 7 because she was the actress, portraying 7 of 9, which is a character in Star Trek Voyager. See, I still remember that stuff. And I didn't even study. Okay? But are the concepts okay? Okay, so if these concepts are okay, we'll get into another one. This one is going to be a short program, but before we move on, let me just double check. Okay, are there any further questions about this trace? No, okay. Now, if you're kind of thinking, well, I get most of it, but not entirely, you might want to consider re-watching the video, and this time, pause, okay? Pause when you are not fully getting something. Think about it, jot down some notes, okay? And then resume when you think, okay, I think I got this, then resume, okay? Because in the class, I cannot just stop, because, we kind of have to keep a pace going in the class. All right, so let's go ahead and start with another program, okay? So this one is define sub GT, okay? I'll just call it GT. It has 2 parameters. One is X, one is Y, and what it returns is X is greater than Y. That's what is GT, greater than. Okay, and define sub. Pretty awkward as a function as far as what we have been exposed to, but in terms of what it does, it is no different from any other programs that we have seen. And then inside in another subroutine, okay, let's use another subroutine that we call main. Okay, we say, if invoke GT, we say 5 goes to X, and then we have 7 goes to Y, then print greater than, else we print not greater than. And if n defines sub, and then we have invoke main, it's the only thing outside of a subroutine definition. So I'll go ahead and fix the indentation first, and then we'll see what happens when we trace this particular program or pseudocode. Okay. And if you talk to other people who are currently or have taken cisp300, many of those people will tell you that they do not get to recursive subroutines, or what we just talked about. Now, then you ask why? Why am I so insisting when it comes to recursion and getting through recursion? Because I think if anyone claims that that person understands subroutines, then recursion should be no different. Recursion is not a difficult concept from the perspective of tracing. It is a difficult concept when it comes to, I want you to write a recursive subroutine to do X, Y, and Z. That gets a little bit complicated. But when the question is, here is a recursive subroutine, trace and find out how it gets things done, it should not be a difficult question. Okay, so there's that differentiation. All right, so getting back to this particular program, which is a new thing that we are doing, let's figure out what this is going to do. Okay, so this time we have the invocation in a very awkward place. Yes? Where's the invocation? It's on line 7. It is taking the place of a condition, right? So the question is, well, how does that work? Will the mechanism that we have talked about so far get this to work? That is the question. All right, so let's see how the trace is going to look like. We got comments, we got line number, we have no global variables, so the precondition really has nothing to say. The only one line that is outside of the definition of a subroutine is line 13. It calls main. Main does not return a value, so we can be a little bit lazy and just return line number, which is post. Okay, are we good so far? Yes? Yep.
Okay, on the last subroutine, it wasn't post before. Okay, on the last one, you started with the last line of the code, and it wasn't posted. You kept it on the line
What?
of the code. I don't know.
He's doing return info there instead of return line number.
Oh, okay.
Yeah, this is a return line number because main does not return a value. Okay, so that's pretty much all we need to do for column C because main has no local variables, it has no parameters whatsoever, so we are quite done with setting up that column. Then we get to line 7. Line 7 says, well, if I can, this is a conditional statement and I want to decide whether to move on to line 8 or line 10. But can I? Nope, I cannot, because the Boolean expression or the Boolean value that I need to determine which way to go is the return value of a subroutine. I have to invoke the subroutine first, get the return value, then I can decide which way to go. Does that make sense? So what do? We have to do the invoke first. What do we do when we invoke a subroutine that has a return value? Because GT has a return value. What do?
Next column.
Okay, allocate the leftmost available column, label it return info. And what should we put here? Remember, the whole idea of a return info cell is to remind us where we need to go back to and what else do we have to do once we get back. Okay, so that's a good start. Which line are we supposed to go back to? It's line 7. And then what do? Everything there except for the invocation, which is replaced by a question mark. That is what we do. Is that okay? So once again, the question mark itself is replacing the invocation that we are dealing with at this point. We are trying to invoke GT, so the invocation of GT is the one that is replaced by a question mark. The question mark is a placeholder of the return value that hopefully we'll get later on. Is that okay? So this is how we set up this return info cell, but we also need parameter x and y. So those two, x has a value of 5 and 7 has a value of y has a value of 7 because that's how we pass the arguments. And then we continue execution in GT, which only consists of one line, which is line 4. Are we okay at this point? Okay? So what do we do on line 4? Line 4 is a return statement, which means whatever the value is to its right-hand side is what I use to return. X is greater than y. What value is that? False. Very good. Good job. So we look at Boolean expressions just like any other expression. Instead of giving us a numerical value, it's still giving us a value, except this time it's a Boolean value. It is either true or false. Instead of 16 or 5 or 2 or 3, it's just giving us true. Okay? So line 4 is saying return true. What do I do when I execute a return statement that has a value of true? False. What do we do? It's extremely mechanical, isn't it? We retrieve the crumb that we left behind first, right? Which is the rightmost column that is labeled return info. That's column D. Copy and paste it, right? And replace the question mark, which is a placeholder for the return value, with the actual value that we are returning, which is false. Done. That's what we do. And we're done with line 4. So when we're done with line 4, we move on to line 5. Okay, line 5 doesn't do much, except it is the end of a subroutine. So it's got a few things to do. The first thing is to make use of the crumb that we left behind, which is the rightmost column that is in use and labeled return info, right? Column D, that's my crumb. I want to make use of it. In other words, I want to copy and paste it into the line number column so that I know which line I need to go back to and what else do I need to do on that line. So we copy and paste it. Then we have no use of these 3 columns anymore. So what we do is we mark these columns so that they can be reused if we need to. So we strike through, and now we continue execution on line 7. But line 7 is not line 7 in the original source code anymore, because the invocation is now replaced by a known value of false. Okay? So this is going to be quite interesting, because what do we do on the column, the comments column? The only thing we can really say is false is false. It is very stupid, but it is just false is false. Okay? So what do we do when the condition of a conditional statement is false? Where do we go? Go to the else, right? Which is line 10. Very good. So now we proceed to line 10. And the only way we can track, printing something is we just, write it here, print not greater than, because we don't really have an output, per se, of, from this pseudocode engine. So we just kind of, write it down as a comment. And then where do we go? Line 12, which is the end of the main subroutine. Once again, we have to retrieve the crumb that we left behind. But this crumb is already consumed. You just ate it. Okay? Just think about, what is the story that where a character went through a forest and was trying to leave behind crumbs? Okay? So as you backtrack, you're eating all that crumb that you left behind. Okay? So we have already eaten column D. So the only crumb that is left behind is column C, which tells us, okay, let's continue on to post. Okay? So we write it down here, post, and then we eat this column too, right? So we are consuming this particular crumb and say, that's gone. Okay. And now we continue at post. We're done. Yep. Why is false false? Well, because, okay, so the first false is coming from the expression itself. The second one is just to say what is the value of that expression. In other words, this is just copying from the expression, from the conditional statement. This one here is the value of the expression. So because the expression itself is a constant of false, so the value is just false.
On the homework assignment, I did the 3 red lines and I thought I'm doing wrong. I tell the younger because I wanted to find P and I couldn't. I was like, should I jump on the P or not? And I didn't submit it to you. Is it okay
Okay.
to do that and send that to you so I can get some points?
I do not accept late submissions. Yeah, but I can grade it. I can tell you whether your trace is correct or not. Yep.
Because
But
I
you
did
cannot
half
even
of
turn it
it.
in.
I didn't turn it in. I
Okay.
just did half of it on my laptop and I thought I was
Okay.
doing it wrong. So I wanted to do it here and help it out with something.
Okay. So as I said, I can grade